community, and they can eliminate some of the volatility in their fuel markets. I'm going to show you now the 20-ton machine and go through some very, very basic things of it and what we've done with it. So we have, basically, this is the left side of the machine. We have this plastic goes into this feeder here. It then goes up and drops into another one, up and across to, this is our large reactor. That was the large unit that you saw everyone pull out. It has like this, it's called a refractory oven. It's a rotary oven. Basically, there's a furnace behind it that heats it. That furnace, by the way, is run on our own natural gas from our feedstock. What's very interesting is the natural gas comes, after it's burned, it comes out of this port here and out through a condenser to cool it. This is the second half of the machine, which basically shows the fuel comes out of our large processor into the big condenser, into this temporary tank, which is then pumped out into an oil tanker. Our fuel then goes back up through the hydrocarbon gas goes back up through a secondary condenser to ensure that everything has condensed out. It goes into a water seal over here on the end. And now, one of the very interesting things you're going to see about this process, and when we say green, I mean green. I don't mean it's got filters and scrubbers and all kinds of stuff that just is a creative way of saying we're bubbling junk through water to get rid of it so it doesn't go in the atmosphere. But really, you know, you've got this horrible water residue left that you got to deal with. Our process, the gas from the entire closed-loop system goes through this condenser, through this fan, up and out a stack. There are no filters. There are no scrubbers. The air that comes right out of the furnace of this process, the only output of this unit, has absolutely no scrubber on it. It's as clean as can be. This is a side view of the process. Thanks. And that was actually something that excited ILChem too, by the way. When they had that little unit there that was jury-rigged with 100 different things connected to it, they were testing everything possible that came out of it. And so in the end, they helped us design and build a lot of this. So we have modified the Chinese unit that we did buy originally significantly. And ILChem was a very, very important part of that. For example, they looked at us when we got the burners, which run the oven on the right-hand side of this machine from China. They said, you can't possibly in a million years turn that on in this country. It's not legal. They don't care in China. But we had, basically, they just took their fuel or oil and just pumped it straight into a burner. So I thought, well, that's great. We'll just take our off gas and pump it into a burner. And ILChem said, no, no, no. So they found us the right engineers. They've worked with them in many other projects. We actually retained an entire combustion engineer firm that designed our system that automatically cuts over to our off gas to keep the system running. And what's really cool about it is this is the same company that designed the combustion, basically the combustion chambers and the burners for Exxon's rotor reactors for some of the slag that they're trying to convert. They don't have the same process as us, but it's along the same line. So it was nice to have a good, solid group like this that had a lot of experience. And ILChem knows these folks very well. On this side of the machine here, you can see very clearly again, there's the rotor reactor. You'll see that tomorrow. It turns. The fuel then goes up our main condenser. It condenses out into this tank. This is an automatic transfer pump. So basically what happens is our fuel fills up in this tank. When it gets to a certain level, the code that I've written with a group of engineers who we've automated the heck out of this thing basically takes the fuel out and pumps it into an oil tanker on the property. Another very important thing about this unit is ILChem, we've done something unique. We've installed 59 sensors on this machine. So we have oxygen sensors, we have hydrogen sensors, we have pressure sensors, we have thermocouples everywhere on it to give us temperatures. And what we are able to do with the software and hardware that we've designed on our side is track what this machine does every 10 seconds and log it to a huge database for ILChem. So when we pull fuel out of the machine, we can say, this is what happened, and here's how it made, and here's how it got there. Because we've learned something about a reaction that's very unique, and it's really a lot of cool, and it's fun. It's a little scary on some cases, too, because when the reaction starts, it takes off. You put a ton in that reactor, and it leaves in 5 minutes. So you've got to have the back end to be able to cool all that hot gas and condense it down to liquid fairly quickly. So our bottleneck really is how do you manage it and stabilize the system? And fortunately, with all of the automation controls we have in it, it allows us to monitor it, and they can connect in remotely and change the algorithm. I can watch it from my place. Alan watches it from his. Someone will be sleeping there babysitting it 24 hours a day. We have to. And keep an eye on it. This is our combustion system. The Chinese unit was very simply a pipe with a large black thing that looked like a huge Bunsen burner. That wasn't acceptable in this country. So this is what you're supposed to do. So we actually fire this unit on natural gas that comes into the building first. Once it's up to heat and running, that black pipe coming down is our off gas that's then fed into this whole control center that runs the process really and keeps it heated and running. And moving forward, what we have to do now. So ILChem's validated what we've done. It works, it's repeatable, it's scalable. Now what? First thing, get permits and get them fast. And fortunately, we have a lot of people on our side. The municipalities don't want any more plastic. They want to convert it to fuel. They like it. The DEC is helping. They're working with ILChem to get us through the permit process quickly. It's a green unit. They can see that. The chemistry proves it. And the stack test eventually here, over the next couple of weeks, will certainly prove that on a very large scale. So what we want to do is get permitted in New York State and use that permit instantly then to get permits in Florida and Canada. We don't have any control over how long those take. Some areas take longer than others. It's just a fact of life. One thing that is helpful is the stack testing company, CRA, that's testing our stack in New York is out of Waterloo. So it'll be very easy. They're an international firm, so they'll be able to test us for Canada. And they also have offices in Florida. So they can help us move fairly quickly through the permitting process. And you be sure we'll be pushing them as hard as we can. Second part is maximize the Niagara Falls, New York facility. So it'd be nice to go out and set up 20 sites tomorrow and go through the permitting of all that. What I want to do is maximize the numbers to show the true value of what our plastic to oil processor is. And what's the best way of doing that? Fill up every square foot of that factory we bought with plastic to oil machines. Hook them all up to the same stack and let them go. And just keep feeding them. So that's what our first plan is, to really maximize the Niagara Falls, New York facility, get our revenues in from that, show what this unit is truly capable of, what the return is, and then from there, go out and permit other areas. We plan to prove our P2O validity with 2 to 3 running processors. We'll have them running in New York. I can tell you that our Florida management team is very, very eager. So while this is going on, they're working on Florida simultaneously. Our company we love to do things in parallel anyway, and we all work very well together, so we're able to accomplish this. And that's everything I've got to say about plastic to oil. Over here. Thanks. So we've come a long way in 1 year. And plastic to oil, which would usually be one whole business unit, has just been one part of our company. I can tell you I spend 99% of my time now on plastic to oil. I love it, passionate about it, it's a lot of fun. And really, in the end, it's all about, for us, when you saw that hydrocarbon chart, it's about tightening up that graph as tight as we can. And that's just been a lot of fun on the processing side, which is something I'm really good at. And as well, I just wanted to let you know that, we really brought this idea in April. It was a concept then. We had some preliminary results, and now we've got a full-size processor in 1 year. And that's through the help of a lot of shareholders like you that have helped make this happen and build this company what it is. And I can't wait for the next year to report to you where we are and where we're at next year, right here, same time, same place. Thanks so much.